please like turn your camera off or, make the adjustments accordingly. But yeah, so if we're all set up, I guess I'll get started. Okay, so this is the overview of what we're gonna do today. Basically, we're just gonna have like an intro and then a presentation of like the basics of the interface. Then we're gonna do some part demonstrations, assembly demonstrations and drawings. And all throughout, you guys will have practice exercises to walk through all the skills that we teach you. Okay, so just an introduction to SolidWorks. So SolidWorks is a parametric feature-based system. And what this means is that when you create different objects and different dimensions with the software, SolidWorks creates relationships between everything so that you can edit them, and basically your edits roll over to the other things that you do. And you can see more of this later when we demonstrate. So SolidWorks allows you to create 3D parts, assemblies, and 2D drawings, all of which we'll show you today. So I'm going to do an interface tour in a second, but this is just to like warm you guys up and show you some slides. So the first thing that we'll talk about is the feature manager design tree, which is shown over here. So basically it shows all the different features that you make, and you can roll back and forth to go backwards in your design or forwards to different drafts. And then you can also change the view. So that can be shown down here in this little view icon. There's also some important buttons in the top left. So as you can see, you can save your part. You can also go back to home and rebuild in case you make any updates. And we'll go over that more later as well. Yeah, so then these are some important mouse controls that I'll demonstrate later. So I won't read them through right now, but you can just sort of look over them just to get familiar with them. I am using like one of those like computer mouses. So if you are on your laptop, I think it might be like a bit harder for you, but we can definitely help you out with that. So this is the general layout and customization when it comes to SolidWorks. So there are different tabs and toolbars that you see up here, and you can actually, this is me like right clicking, and you can customize which ones you see. You can also switch windows either by doing the control tab on your keyboard, or like clicking these little things to sort of see if you can split screen and do all those little things in SolidWorks as well. And finally, you can apply the scene. So this changes your background, and you can also play around with all these different features that I show here to customize the view even further. Okay, so with that, I will switch over to SolidWorks and show all of that again, but just in the actual software. So as I mentioned before, this is the feature manager tree. And when I hover over these different things, you can see that it points to different parts of the part. So if I roll back, you can see it goes backward a step in how I built the part. And I can just keep going until it's like all gone, and I can bring it back. So I think that's pretty useful. You can also change the views. So I'm gonna move my zoom a bit so I can do that. So I can click around here. There's also shortcuts on your keyboard. So you can hit Control-7 and go back to isometric. Again, there's the buttons in the top left where you can save, or undo is a big one for me, and also rebuild. Okay, now here are some mouse controls. So you can use your middle mouse button. If you just like press it down and move, you can rotate the view. You can also scroll with the middle mouse button to zoom. You can hold control and hit the middle mouse to pan. And finally, you can control and click to select multiple parts of your screen. And then I'm gonna hit escape to get out of all that I just selected. Okay, and finally the layout customization. So I can like right click here, go into tabs, add some things that maybe I want to use. I can also go in here, change the background to different things. And I can switch windows. So this is just a bit of a demonstration of what it's like. I can also switch to something else that I have open. But yeah, that's the basic overview. So now I'll hand it off to Vicky, who will show you more about actually creating parts.
Okay. Hi, everyone. So I'll be walking you through the parts for SolidWorks. Essentially, parts are like the basic building blocks for anything you'll be creating, maybe assembly or just the part itself. And typically, a part is a 3D shape that you will be extruding or revolving using a sketched face. And so because of that, we will be using a lot of sketching tools and extrusion tools to create the parts that we want. So I will bring you to the next slide. So some of the shortcuts Trinity have mentioned already, the Control-7 isometric view, Control-8 normal view, and these are all very useful for navigating SolidWorks. And some of the key ones that we'll be using is the S button. It will bring up a shortcut menu for different commands that we'll be using. And another useful one would be zoom to fit, which will essentially bring you back to the overall view for the part you're drawing. And that's usually very useful when the part gets too complicated and you're zoomed in on a specific part and you want to quickly get back out. You don't have to scroll in and out to find the right position, and you can just use the pressing F or double click the scroll button to zoom to fit. So like I mentioned before, sketching the face is what we'll be using to create the 3D objects. And some of the very useful commands we'll be using to create these sketch profiles are lines, circles, rectangles, and arcs, which you can see on the top right here. And commonly, we will use different tools such as construction geometries to use as references for defining these sketch profiles. And typically the construction geometries are construction lines and center lines, and they're found by using the drop-down next to the line tool. And when we finish our sketch profiles, we'll usually edit them using tools such as mirroring, trimming, or offset, which are all very helpful for simplifying the sketch. Instead of sometimes, for example, if we have a symmetric drawing, instead of drawing the entire face out, we can just draw half of it, use the center line, and then we'll mirror the half-drawn face profile to the other side. For dimensioning, we'll be using the smart dimension command to add in the dimensions of, for example, a rectangle. We'll add in the dimension of the width and the length. And this is very useful for changing the drawings you have onto SolidWorks. Another useful command would be geometric relations. And these are also known as constraints. These are typically used to define the relations between the sketch profiles. So for example, if we have two circles and we want them to have the same center point, we'll be using a concentric relation using the command found at the bottom here that says display/delete relations. The dropdown inside would have an add relations command, and we'll be using that to add the relations. So another useful part or essential part to creating an extruded object would be using extrude tools, revolve tools, and many editing commands. So extrusion tools, there are two different types. One is boss extrude, and it basically adds materials to the face you've created or drawn, and it will turn it into a 3D object. Extrude cut is used to cut into the extruded 3D object. So for example, if we have a block and then we want to cut let's say a hole through it, we'll be using the extrude cut tool on this one face of the block and then using the cut to create the hole. Revolve tools is essentially like boss extrude, except it will be extruding in a 360 degrees method, and it will be pretty useful for creating round objects such as like wheels or like donut shape, which we'll be doing later in the demonstration. And for editing, we'll have fillets and mirror entities. Fillets essentially is used to make sharp corners. For example, for a cube, if we have a sharp corner, and for design purposes, such as to prevent the sharp corner from being too easily breakable, we would add fillets there to smooth it out to make the sharp corners smooth. And for mirror entities, it would be very similar to the sketching tools mirror entities command, except instead of using a reference line, we'll be using a reference plane. It's okay, it's probably sound like a lot right now, but we'll go through these through demonstrating on SolidWorks. So I will go ahead and switch to SolidWorks. So if you guys have the PowerPoint open next to you, it will be pretty helpful to see the points I've just talked about as I demonstrate. So if you look on the top, oh, did someone say something?
Where is the PowerPoint?
I can put the link in the chat, like as
Okay, thank
Vicky's
you.
demonstrating.
Yeah.
Oh yes, Trinity will be sharing that right now. So I guess I would give a little short while for everyone to open the PowerPoint if they need. And if you have the PowerPoint ready or ready to go to the next part, feel free to do a little reaction.
Also, should we all open a new file, I guess?
Yes, open a new file would be great.
And do we do part, assembly, or drawing?
Use part.
Okay. Okay, thank you.
No problem. So don't forget to do a little reaction once you have the PowerPoint ready or is ready to go to the next part.
By the way, if anyone has questions, feel free to ask them both in the chat or over voice at any time. Don't hesitate to stop us if you needed to figure something out.
It looks like most people got it. I guess I'll go ahead and start moving on to the next part. So talking about sketch, if we go to the top tabs here as shown before by Trinity, if you go to the sketch tab, there's a sketch tool right here. And if you click it, SolidWorks would ask you to choose a plane to sketch from. So typically we would choose a plane that is most useful for us in terms of the orientation of the shape we'll be doing. So for example, if I want to extrude this way, I would probably choose a front plane because extrusion will be done this way. So for this example, I'll just go ahead and start a sketch on the front plane. Now, some of the useful drawing tools we use are shown here. So for example, the line tool I mentioned before, circles, rectangles, arcs, and many more. So let's start with the line tool. So SolidWorks has a lot of useful reference lines that they automatically show. So for example, if you look here, you'll see a blue dashed line. This is a reference line from the origin, and it tells you that you're moving at a line that is horizontal to the origin, or here it's vertical. And also when you hover over the origin, you'll see this orange dot, and it indicates that you're pointing exactly at the origin. So I'll go ahead and start a line from origin. And notice that when I have the line at 180 degrees, there's a little yellow icon next to it with the horizontal line. This means that the line is horizontal. So if I click again, it turns green and it's shown here. So this is a geometric constraint that we've talked about before. And SolidWorks tends to automatically add them unless we tell them not to. And not only that, but when you place the second point for a line, SolidWorks doesn't automatically cancel the command. It will continue going until you're done. So this is quite convenient for when you need to draw a complex object, and so you don't have to reactivate the line tool every single time. Another useful shortcut that SolidWorks provides is if you hover over the endpoint, notice how the yellow icon next to the cursor shows these two concentric circles in yellow. It means that now you've changed the tool from line to arcs. So notice when I drag it out, it turns automatically into an arc. So this is very helpful for when you need to draw like curved at corners. So instead of like exiting the line tool and then reactivating the arc tool, this provides a shortcut for that. So if I go ahead and just place it this way, and it goes back to the line tool again. So for this small, quick demonstration, I will try to create an arch shape. So I will go ahead and bring it back again to arch it back. And notice that the reference line shows again to indicate that I'm now vertical from the center point of the last arc. So I'll place it and continue. Another reference line indicates that I'm now vertical from the origin. Click it and then bring it back to the first point. So now if we look closely, we see that this profile is shaded in blue. This means that all these lines and arcs, they're all closed, which means that this is one complete profile. So SolidWorks will automatically make it shaded blue. And it will also end the command for you because it knows that you're done with a profile. And for example, if I delete this arc and this arc by selecting them and pressing delete, and let me activate the circle tool. I'll find the midpoint here for this line and bring it over as a reference. And when it's vertical from the endpoint shown here, I'll click it and add a circle here. So what I'm doing now is showing you how, if you notice that the shaded area changed to the circle only, this is because SolidWorks recognized that this is a closed profile, but it did not think that these three lines are connected to the circle to create the profile. So if I want to create the arch shape again, I can use the trim tool to remove this arc here to reconnect this profile into the arch shape we had before. So if I take this trim entities and slide it over, and it's back to the original profile we had. So that's what the trim tool is for. The next one I'll talk about would be the mirror entities command, which is found up here. So if you look in the description, it said that we need to have a center line or a planar reference in order for the face to be mirrored. So to do this, to do the center line, it can be found in the dropdown next to the line command here, found here, center line. Or like I mentioned before, the shortcut by pressing S on your keyboard, it will show this tiny little window. And if you look here, there's a smart dimension command for dimensioning. There's a line command, there's the rectangles and all the sketching tools we see before. It even includes the trim entities command and the offset entities command, which we will talk about later. So I'll go ahead and go to the dropdown for line and activate the center line. And I'll draw a center line through here for if I want to create a mirror image of this face on the other side. So I'll bring it over. And now I'm ready for mirroring. So I'll activate the mirror entities command and you will see this dialog box show up. Here you see that entities to mirror is highlighted. It means that this selection tool is active. So I'll go ahead and select this face. And automatically you see that all the sketch entities we did before to create this face is automatically selected. So it looks good. So I'll go ahead and change to the selection box for mirror about. So mirror about selection box is essentially for choosing the reference plane or line that you'll be using for mirroring. So in this case, we'll be using this center line that we drew before. So I'll click it. And you see that the arch shape we did before is automatically mirrored over. And the preview looks good, so I'll go ahead and click check. If you look here, there's actually two different shades of blue shown inside one profile, but we want it to be the same profile. And what's causing these two to be registered by SolidWorks as two different profiles is because of this line in the middle. So I will be reactivating the trim entities tool that I used before, and I'll rid of this line in the middle, and then the shading automatically changes to the same color. So now it's one complete profile. Now for dimensioning, we'll be using the smart dimension tool from the upper left. So if I activate it, I can define any lines or distance between center points easily. So if I click this line and bring it out, and you can see that we can define the dimensions. So for this example, let's do, let's say 125 millimeters. I'll click the green check. And the dimension is added. So I'll go ahead and exit the dimension tool. And that's basically the dimensioning command. Now, the last command that we will talk about for this small demo would be the offset entities command. And what it does is basically it will offset the exact same profile you did in any direction that you define. So if I activate this command and the dialog box shows up, you can see that under parameters here, you can define an offset distance. So if I click this profile we drew, oops, let me Control Z and reactivate the offset entities command. Select this profile again. I think there's a little lag. Oh, here it is. So you can manually drag the different distance and then click to place it. You can also change it to be inside or outside, and it will automatically add a new profile for that. And the offset entities command is done. So,
Fun fact. Oh, go ahead. Go ahead.
oh,
Sorry.
did you want to say something, Jeremy?
Yeah. I was going to say, fun fact, this is very, very useful if you're dealing with trying to draft for example, a box with hollow walls. Instead of having to take two profiles and then a cut, you can just use an offset to extrude a thin profile and be done with it.
Yes. So I'm actually going to demonstrate what Jeremy just said right now. So if we exit this sketch, which means that we're done with it, we'll go back into the graphics window that we were in the beginning, which is now in a different environment. And if I rotate a little, you can see that it is just a 2D face, which is what we created. And to make this into a 3D shape, I will activate this extruded boss/base command on the top left. So if I click it, you see automatically a preview shows up. And you can define this extrusion further by coming over here, and you'll see there's a blind extrude. This blind extrude essentially lets you define how far you want the extrusion to go. So the parameters for defining how far it would go would be down here. If you click this blind dropdown, you also see that there are many other options for doing the extrusion. So for example, if I pick midplane, like the name indicates, it's now extruding from the midplane to both sides. If I change to, so the rest of these four, these are actually extrusions based on the reference object. So for example, if we have a reference plane, the up to vertex, like the vertex on that reference object, surface offset will be offset. It will be extruded to the distance offset from the reference object, and up to body would be essentially up to the reference body. So we'll be using the blind extrusion here, and let's give it, let's say 50 millimeters. And the preview automatically updates. So if you don't want the extrusion to go in this direction, you can easily flip the direction by clicking this button here, which is reverse direction, and it's changed. Its extrusion direction is changed immediately. So the extrusion looks good, and I will go ahead and click the check mark, and it's complete. So the extruded cut is basically, let's say that there's no center hole here that we see. This is not hollow, and we wanted to make it hollow. So we will be drawing this same face profile inside, and then we'll use the extruded cut command to cut that profile. And the different types of extruded cut is very similar to the extruded boss and base, so we'll skip that. But like Jeremy mentioned before, for typical design intent, this can, by drawing out the parts with an offset command, we can save several steps. So instead of having to draw a second profile and then use the extruded cut feature, we can just extrude the hollowed shell by itself. Now for the revolved boss/base command, this, like I said before, is used to revolve a cross-sectional profile around a reference axis of reference. So to demonstrate this, I'm just going to go to the sketch command again and then draw the profile I want to use. So while I'm sketching, notice that here there's a little drop down. If I click it, This is actually the features tree, again, shown here. And you can use it to quickly select whichever plane or any features you've used before. So let's say I want to draw on the front plane again, and use Command 8 to bring myself to a normal view. I'll quickly draw a small circle. Exit. And let's say we want to revolve the circular shape around this direction. So that means we want the axis of reference to be up here, since it will be revolving around the axis of revolution. So I'll go ahead and go back to the normal view and activate the centerline command again. And then I'll just draw a horizontal center line up here. Click exit, and we're ready for the revolve tool. So I will go ahead and exit sketch and go to features tab again and choose revolve base, boss/base. And automatically SolidWorks registers that you drew this cross-sectional area before. So it will right away, and it will select the axis of revolution by itself. So it's actually this tool is actually very useful for creating wheels and adding holes in them later, compared to using the extrude boss base command, which is actually, I don't think it's possible actually, but this is why it would be a very useful tool. So go ahead and click the green check, and it's complete.
Wait, can you go back? I'm still getting stuck on like just the extrude tool. Like I can extrude it, but it's like I can't get the hole in the middle.
Oh, okay. Let's see. If we go to the sketch and then we right click it and edit it, does your drawing match mine? Because sometimes like SolidWorks doesn't, if it's not too close profiles, and sometimes it wouldn't register it.
Okay, yeah. And then we go.
Make sure that these are 2 different shades of blue, right?
Yes.
And I'll click exit. I'll go to the boss extrude. So you can easily edit these features by right clicking them and then choosing from a shortcut menu. Does it not extrude like this?
Let me see. Yeah, because I can only select like one of the lines when I use the extrude command.
It could be because it's not connected. Actually, could you share a screen? Maybe we can look at it.
I'm actually using a different computer for my SolidWorks right now, so I can't.
How about this? Can you send a screenshot to one of the, like to either Trinity or Caitlin or Jeremy?
Okay.
And they can probably look at it and try to help you out with it. Does anybody else have questions or is running into a similar problem? I'm gonna assume that's a no. Wait, chat. Okay. Then I guess we'll go ahead and move on. We pretty much covered all the extrusion cuts commands and the sketching commands that we mentioned. So I think we're ready to move on to the parts demonstration, where we'll be creating an actual part using all these commands that we've talked about. So if I sort back to the PowerPoint. So this will be the part that we'll try to create today. If we look closely at it, we can notice that this half and this half are the same. So they're symmetric. That means that we can use the mirror tool to easily recreate this entire part. And not only that, but if we look at this rod holder, it's also symmetric to each other. So that means when we draw the face profile for it, we can use the mirror tool to mirror this half of the profile to this part. And also the holes seems to be placed at the same dimensions from the sides of the part. So we can probably use a mirror tool for that also. So I guess let's just get started. If you guys have the PowerPoint open, it will be pretty helpful because I will have the dimensions I'll be using for drawing different parts in the PowerPoint. So it'll be easy to follow along, but if not, then you can just follow step by step with what I'm doing, because I'm just following what I wrote on the PowerPoint. So if I swap back to SolidWorks, I'll go ahead and start a new part. So if you guys see here, new, there's a little drop down. This one, you can make a new part. You can do drawing from part assembly or just doing assembly. For this one, we'll just be using new because we want a new part. And a little dialog box shows up. So with part selected, we'll click OK. Now, one key point that we have to point out before we get started is I did the component in the MMGS units. So if you look on the bottom right here, it will show the different unit systems. There's like IPS, CGS, MKS. So make sure that you're put on MMGS so that the dimensions will actually work instead of being the different unit system. And for the sake of easier view, I'll change the background to plain white. And let's get started. So step one, we'll be drawing the shape of the base. So it's essentially a rectangular shape with a little rectangular bump in the middle. So since it's symmetric also, we'll be using the mirror tool again. So as you can see, the mirror tool is actually pretty helpful for doing symmetric parts. I'll go ahead and go to the sketch tab and then press the sketch command. Since the extrusion seemed from the presentation of the completed part seemed to be this way, I'll draw on the front plane. And once we're in the sketch environment, I'm gonna go ahead and activate the line command and start drawing. So if I'm going too fast, just let me know. I can slow down, or if there's any parts that's not going right, like feel free to send screenshots into the chat, and Trinity and Caitlin will help you guys out. So if I go to the origin and start drawing the general shape of the half of the part. So notice how I didn't close it. This is because if we want to mirror it, we don't want, like the demonstration I showed when I mirrored it with the profile closed, it included the center line. And we don't want that because we want this entire profile to be the same profile. So I'm just going to go ahead and leave this empty. And then use my helpful shortcut window and then select center line and draw a little construction geometry for mirroring. Now that this half is done, I'm going to go ahead and activate the mirror entities command. Select these entities I want to use to mirror. It looks good. I'll change to this selection box. Select this line, and it's automatically mirrored. Click check mark, and profile is done. So now we're going to go ahead and start defining it. So I'll activate the Smart Dimensions tool and start adding in the dimensions. So this part is shown as 18, side to side. And it's fully defined. So I'm able to tell that this profile is fully defined because if you notice, all the lines have turned black, which means that none of the lines is movable because they're locked down by a dimension. So typically we want, well, actually always we want to make sure that our profile are completely dimensioned and constrained, because we don't want that when we do add a different profile later and one of the part is loose and we accidentally move it, then it could ruin the entire part. So now that this part is ready, go ahead and exit and activate the extrude tool. So in the PowerPoint, it said that we wanted to extrude this base shape by 50 millimeters. So I'll go ahead and type 50. It feels kind of awkward for it to be extruded in this direction, because if we want the mirrors to be this way, we can just use the mirroring of this plane. And also the origins here. So for like isometric view simplicity purposes, I'm just gonna flip it. But either way, it's fine. So I'll click the check mark since all the dimensions are correct. And move on to sketching the holes on the top face. Does anyone have any questions so far up to this point? See something in the chat. Oh. I guess that's a no. So since we know that the holes are up here, then that means I want to draw these holes onto this face by looking at it normally. To do that, easy way is to click it, and then you see this little shortcut menu coming up. Over here, there's a little normal to command. If I click it, it automatically brings me to a normal view. So let's see if we can rotate. Oops. I'll go ahead and just start the drawing sketch command on this face here. So if I click it and activate the sketch command, I'll be now sketching on this plane. So we'll draw the two circles for the holes on the top here. Since the other one has the same dimension, I'm just going to go ahead and draw one of them, define it, and then mirror it over, because the dimensions will also mirror over. But don't forget that we also need a construction line to do that. So I'll quickly add a construction line in the center from the origin to the midpoint. And I'll go ahead and add in the dimensions. That will also be mirrored over. We want the diameter of the circle to be 8.5. The distance from the center point to the edge is 35. Now I noticed that the other dimension given is from the center point of this circle to this circle. But since we don't have that circle yet, we can first mirror it over and then define it. So if I activate the mirror entities tool, I select it. So quickly here, there's actually another shortcut while using the mirror tool. Is when you select a profile, notice how my cursor has a mouse and there's a green arrow shown on the right button of the mouse. If I click it, it automatically switches to the mirror about selection tool. So if I go ahead and select it and click that green checked mouse button again, it automatically completes the mirror command for us. So I'll add the last dimension from here to here to be 40 millimeters. And both sketch profiles turn black, so we know everything is fully defined and it's ready for the extrude cut. So I'll leave the sketch environment and activate the extruded cut command. Automatically, SolidWorks registers the two profiles we drew and does the cut for us. Since it's kind of unnecessary to define the blind command to be 50 millimeters, since it's cutting all the way down here, we can just swap to a through all cut. So what this does is it will cut through any parts that it runs into in this direction. So this is actually a lot more useful than just a blind cut, because if we ever decide to add more material to the bottom of this part, let's say the blind cut, we said it's only up to this edge here, then when we add the extra material in the bottom, it will only cut to there instead of cutting through the whole material, which is what we want the whole to be. So if we, by defining it as a through all cut, we won't have to deal with that problem later. So I'll go ahead and click the green check and the holes are created. Now for the next step, step 5, we'll be drawing the profile on the side of the base using the dimensions given. Now, if we look at the slides, we notice that the rod holder is actually on this side, not on this side. So that means we want to draw on this face here instead of on this face for simplicity purposes, because otherwise we will have to use a reference material, a reference object to use the extrusion, for the extrusion to come from this side. So I'll go ahead and click here again and use the normal tool command again. And I'll start the sketch here and start drawing the lines. So the arch starts here. I'll use a quick shortcut to change to an arch tool, reference it to the origin, and let me quickly add the line from here to the origin. Then I will use the construction to do the mirroring command. So mirror entities, select these, right click, select the center line, looks good, right click. And just like that, we're done with half of the drawings. Then it needs a little circle in the middle. So I go ahead and come here and draw a circle. Now notice that the circle and the arc actually is not concentric as shown in the figure. So to add that constraint, you can go to the display/delete relations command up here, click the drop down and select add relations. And the add relations box window will show up here. Here you will select the entities that you want to define a relationship between with. So I want to define a relation, a coincident relation between this circle and this arc. So I'll select the arc and the circle, and we can use any of these relations shown here. I want concentric. And notice how automatically SolidWorks makes it concentric. And it's now added to the existing relations command here. So I'll click OK, and the constraint is added. So now let's start by dimensioning this profile. So we want an angle 95 degrees. Diameter of the circle 14. And from the center point of the circle to the bottom line should be 12.5. Now notice that even though oh wait, actually one more dimension. This line here should be 25. And notice how it is now fully defined. If, let's say, you've added all the dimensions and then realize that, let's say, this arc is blue, but everything else is black, then you know, oh no, this arc is missing a dimension or a constraint. You can usually easily check what they are by clicking here, by clicking the display and delete relations. And you can look at what relations is here to decide if anything's missing. So going back to the same problem, if the arc and the line is not shown in black, it could mean that it's missing a tangent constraint or a concentric constraint with a circle here. So this is actually a pretty convenient way to check if why a certain sketch profile is not fully defined. So anyone has any questions, or their sketch is not fully defined? Guess not. Okay, that's great. So we'll leave the sketch and now extrude it. Let's go to features and click extrude boss base. And we see that it's extruded in the wrong direction. So I'll swap the direction. Since for this extrusion, we're defining it by a certain specific distance, we'll be using the blind extrusion. So I'll use 25 millimeters. Everything looks good. I'll click check mark. And half of the entire part is already complete. So now we'll just use the mirror command to mirror this half to the other side. So notice here that on the mirror dialog box, it has the mirror face / plane. So this is like the reference line we used when we were in the sketch environment, except now it's a face or a plane. So since we want this part to be mirrored this way, let's choose this face here as the reference plane / face to mirror about. Now, this doesn't look very correct. This is because we did not select all the features that we wanted to mirror. So to do that, you can either select the features we want to mirror inside the graphics window, or like before, if we go to the drop down here, we can easily select the specific features we created that we want to mirror. And automatically everything's mirrored over. Looks good, so I'll click the green check. And the mirror is complete. So now the part looks complete, but actually we haven't added the fillets used to meet the design intent for the part, which is to make these corners and sharp edges to be less breakable. So to do that, the fillet tool can be found here. We will use a fillet and just fillet this entire part down. So if I activate it, you'll see that there are different fillet types. There's a constant size fillet, there's a variable size fillet, face fillet, and full round fillet. So these are different types of fillets, but for now, we'll be just using the constant size fillet because we want it to be defined by a specific radius. So this box here, like before, it's a selection tool, and it will show which part you have selected to fillet. Now notice when I click the second edge, the preview disappeared. This is because the radius we defined was too big for the part to take. So it was not able to show a preview. Now to change that, let's change the radius of the fillet to the correct one we want, which is 1.5 millimeters. And the preview is back. And now at this point, go ahead and just select all the edges that are shown in the PowerPoint slide. So that's pretty much every edge except this top rectangular shape's edge. So click here. If you ever select the wrong edge to fillet, you can go ahead and just click it again. Oops. And it will cancel it. Or you can come to the selection tool here and select the specific edge that you want to not fillet and just click delete, and it will remove that edge. Go ahead and select everything. Don't forget the 4 corners. Looks like all the necessary edges are selected, and I'll go ahead and click check. Now the reason why I didn't fillet this rectangular top right away is because the fillet, if we add the same radius fillet to it, it will actually not show, and an error would appear because of the edge distance differences. So go ahead, I'm gonna restart the fillet tool again and update the fillet parameters to 1 millimeter, and then select all 4 edges again. A little shortcut would be just clicking this face, and it will select all the edges that are on this face for you, and then fillet all these edges for you. Sometimes we don't want to do this, is because if there's specific ones we want to cancel, or the part is super complex, it might actually be easier to manually select the edges than just clicking the entire face. So it depends on the different situations. Now this looks good, so I'll go ahead and click the green check. And our part is complete. I'll move back to the part one. So does anyone have any questions before we move on? Like for example, the fillets not looking the same, or the sketch profiles are having dimension problems, are not fully constrained. Looks like that's a no. Okay, I'll go ahead and pass it on to Jeremy now to talk a bit about design intents before we move on to assemblies. So I'll swap back and I'll stop share.
All right, let's see if I'm able to screen share. Let me see. Trinity, is screen share enabled on my end?
It should be. I made you co-host.
Okay, it's showing a disabled participant screen sharing. So
Okay, I just enabled it again.
all right, let's try that. Okay, so we go to the presentation slides. That should work. Back here. All right, so let's talk about a little bit about correct part design and what design intent really means. Let me bump it back. Slides. The design intent is the practice, excuse me, of expressing through the features, dimensions, and whatever else you have on a specific part, what you, as the engineer, the designer, the person who's making the part, what you want from this specific part, how specific assembly, design, drawing, and this is actually one of the most important concepts with dealing with how to properly design a part. And a couple basics of, let me answer this question real quick. Actually, I'll deal with it later. What are the benefits of designing a part with correct design intent? It makes it much easier to deal with modifying existing parts or fixing them. So something you'll learn if you go into engineering, if you go into, for example, like an internship with various different companies, is that they heavily use what is called revisions, which are, hey, there was a problem with this part, or there's a problem with this assembly, or there's a problem with something. We got to fix it. And sometimes it just might be, oh, this thing was a little bit too small or a little too big, or the company that we were ordering from, that the part that's supposed to fit in here, for example, like an air filter or something, has now changed the dimensions of the air filter, so we need to change dimensions of our part that it fits into, right? So it'll be just these basic little things like that that will require you to change something. And if you use correct design intent, it means that you can go back in, you can fix it much, much more easily. The other thing with design intent is if you give the part to someone else to work on. Say somewhere down the line, someone, you've moved on from a company, or you've moved to you've been promoted to whatever job, and some intern rolls along and says, all right, I got to fix this thing, or I got to change this thing because of whatever reason. The intern picks it up and says, I have no idea what this part's used for. And sometimes, when you're dealing with engineering, when you're dealing with fixing a part, you might not know exactly what the application of this part is. But if you use correct design intent and you're designing your part, the person who's looking at it can kind of infer, can kind of figure out, what is this thing supposed to be for, right? So remember, engineering is both designing parts, and solving problems, and being able to explain what you did to the next guy down. I'm gonna bop it over one slide. Oops, my bad. So let's go back to step 7. Let's talk about the mirror feature. This is a really good example for talking about design intent. I could easily just, do the same thing on the other side, make the same part without a mirror, extrude this feature, switch my screen share over to my SolidWorks window. I could easily, like, for example, this boss extrude 1, I could just instead extrude it to 100 millimeters, put a new, like, make these holes 4 holes instead of 2 holes, and skip the mirror entirely, right? But in the case of this design, since you want both these 2 loops to be the same, that's doing the mirror instead of just doing every feature independently is an example of good design intent. You're saying, okay, well, I want a symmetrical part, and so I'm going to design the part in such a way that the actual build in SolidWorks is also symmetrical, and it's implied through the mirror. However, let's say I need this somewhere, like, if I'm making a line of products where all of these, like this top one might be a little different from this bottom one, it might be shorter, it might have a smaller hole, then suddenly this way of making it becomes poor design intent, because that's not, the intention of the part is not for it to be symmetrical. So moving on to the next slide, let me switch my screen share back over. Sorry about having to keep bouncing between these two. So in summary, there's many ways to make any given part, but there's a limited number of good ways to make that part. And a good way to make that part depends on, what it's being used for, what its purpose is, and therefore its design intent. I have a couple examples, and I'll go into one of them right now. I was working on a test box for my job for essentially a stack of printed circuit boards. So you have 4 of these things in a stack, and there's a faceplate, and the faceplate like screws into a front panel. So you have like this cutout, like you have this box, right? You have this cutout in the front, and you have screw holes near the side for mounting the faceplate. You put the screws through the faceplate into the panel, and there's like a little nut in the back that you screw back on and holds it in place, right? That's all good and fine. Now I go and say, okay, I gotta make the box longer, right? Because I need to put a new panel on the side for like for controls. Need to put a new, I think I needed some cable outputs there. So I try to make the box longer, right? That's pretty simple, right? You just, for example, you would just like change the lower dimension of the lower part of the box to, hey, just make it longer, make it 400 millimeters instead of 300. It's pretty simple. Now the problem is the cutout for the box moved, which is, makes sense, which is expected. The drill holes in the sides next to the cutout didn't move. And so I looked at what happened, and whoever designed that part in the past had dimensioned the drill holes. I'm sure you guys have all covered the dimension tool, right? We just went over it. We covered dimension tool. They'd drawn the dimension. They put, it needs to be X number of millimeters from the center of the box instead of from the frame. That's an example of very, very poor design intent, because and I wish I had the file to show to you guys, but unfortunately it's on my work laptop. I'm pretty sure it's intellectual property, and I'm pretty sure I could get fired if I showed it to everyone, so might not be a good option. Moving on, that's an example of very, very poor design intent, because the purpose of those holes, going back to the good way to make a part, the purpose of those holes is to be a certain distance from that giant cutout in the middle of the box, so you can drill the you can mount the circuit board stack onto. Now, the good design intent would have the holes inside of the holes next to the cutout dimension a certain distance from the cutout. That way, wherever the cutout moves to, depending on what we need, the holes will always be right there, because the holes aren't going to need to be anywhere besides a certain X distance from the cutouts. So that's an example of bad design intent and good design intent. In the end, it made the same part, but once I had to go in and try to change something to fix it, the badly designed piece got messed up, and when I changed it to be a weld, like to dimension the holes to the cutout, no matter how long I made the box, no matter where I put that cutout, the holes always stayed in place, and in practice, the circuit board will always properly mount onto the box. And there's a lot of different examples of design intent that you'll run into in your future, but really getting to understand this concept is critical to making correct parts. So once we cover assemblies and you guys make some more parts, we'll revisit this concept. But for now, I'm going to hand it over to, stop my screen share and hand it over to whoever's going to do assemblies.
That is me. Thank you for
I'll
that.
hand it over to Caitlin.
Okay, let me share my screen. Okay. You can't see my Zoom, right? All right. So I'm doing assemblies, and basically, as Vicky showed you, you can create parts, and assemblies are for when you finished making all your parts. Say you've made a model of your prototype, and now you want to see it actually fleshed out in CAD. That's what assemblies are for, because in parts you can't put like screws into sheets or anything like that, but in assemblies you can. So, oops. So parts, like I said, are the components of an assembly, and there are two methods to design your assembly. One method is called top-down, where you model your parts in the context of your assembly, but we won't be going over that because that's a little bit more complicated. We're going to be focusing on bottom-up design. So basically, as Vicky showed you, you design the individual parts, and we're actually going to be using the part that she designed, and then you insert that into an assembly, and then you add mates in order to piece your pieces together. So say you want a screw to fit in a hole, you can use mates in your assembly to design that. And your parts won't change unless your part files are updated. So in order to create an assembly, you're just going to go to create assembly file under file, new, and then make assembly from part. And you can also insert components by using file and then make assembly from part. I'll be demonstrating all of this also after I stop talking about it. There's a couple different ways to insert parts into an assembly, and a lot of these are very helpful. First, you can literally open your file explorer and drag and drop your files into the SolidWorks environment, or you can open your part window and drag it into the assembly environment. You can also hold control and drag the part names from the feature manager tree and drag that into your environment, and it'll also pop your part into the assembly. You can pin this icon. You'll see when we use SolidWorks that, this insert component property manager pops up when you try to insert a component. And if you click one and add one, it'll disappear. So to prevent that, you can click this little pin icon at the top, and it'll keep that there until you're done adding all your files in. You can also rotate parts before you add them into your assembly by using a checkbox called Show Rotate Context Toolbar, which I will show you in a second. You can also position your parts, left click and drag to move your components around the screen. And you can right click and drag to rotate your components around the screen. And there's also something called Fix or Float, where you can lock your part onto your screen so that it won't move around if you try and drag it. And if it's floating, then you can just drag it around however you like. And then we get to mates. So mates are the most important part of any assembly. They're the assembly equivalent of sketch relations. So basically, instead of creating relations between 2D lines or arcs, you're going to be creating relations between the 3D parts that you create. And some of these are angle, coincident, concentric, distance, log, parallel, perpendicular, and tangent mates. Angle is basically what it sounds like. If you have a hinge, you can change what angle you want it to stop at to make it close on a door or something. Coincident makes parts and their faces on the same face. And then concentric, you can mate round cylindrical faces with other round like holes. And I will be demonstrating these to you. You can also analyze assemblies. So this is a really useful tool in SolidWorks. You can actually analyze its mass properties. And by doing so, you can check how much it weighs. You can check its center of mass. You can check its moment of inertia and things like that. And this helps you to spot problems and make necessary design changes in actual prototypes that you build. Say you want to build like a prototype of your part, but it's pretty expensive and you're not completely sure if it's going to work. So you can test it out in SolidWorks first by using that mass properties analyze tool. And so if you look at that PDF that we linked in the presentation, there's a couple steps for you to follow, but I also have all the steps listed in my presentation if you'd like to follow along with my demonstration. But before I start this, I'm going to show you a little bit about the different commands that you can use in SolidWorks in an assembly. So let me start sharing SolidWorks instead. Here we go. All right, so this is a part that I made in order to demonstrate some of the mates. And in order to create an assembly from this is a part file. So I'm going to go to File right here and then go down to Make Assembly from Part. And then it'll take a second to load because my laptop is slow, but it will eventually bring me into an assembly file. And my part won't be in the window yet, but it'll drop down this little property manager called Begin Assembly. And it's saying part assembly to insert. So I have all of my documents, all of my parts open right here, and I can just click them and click the environment window and add it. And if you see that I click this and then click right here, this property manager disappears. So in order to keep it there while you're adding parts, you can go back to File. Oh, not that. You can go back. You can go to Insert and then Component and then Existing Part or Assembly. And then if you click this little pin icon right here, it'll keep it on there while you add your parts in. And there are also a couple different ways that you can add parts. Some are a little bit more easy to use than this one. So one that I really like is just opening up your File Explorer right here. And if you go to desktop, actually, I have all of my parts right here. So if you just want to drag and drop your file in there, you can. So if I want this part in my assembly, I can just drag it and it will add it into SolidWorks. Oh, that's huge. Okay. And then, so that is one way to do it. Another way that you can do it is clicking Control and dragging the name from here. So say I want another one of these blue blocks right here, I can just hold Control and then drag it into the environment window. Another thing that you can do is you can change your window right here and you can tile it horizontally or vertically, and this will show you all of the parts and assembly windows that you have open. So mine is kind of a mess, but if you also want to add it from here, you can drag it into your assembly window and it'll add right there. And if you want to just go back, you can close all of these. And maximize the one that you want. So now we have all of our parts in our assembly window, and now we can start mating them together. So first, to move them around, you left click and drag. And if you want to rotate, you can right click and drag, and it'll move your parts around. You can also do fix or float. So if you see this right here, how it has an F in it, that means it's fixed. So if I try to drag it with my left mouse button, it'll say the selected component is fixed, it cannot be moved. So in order to change this, you can right click and click float. So now I can move that around freely. But it does help to have a base. So if you have one part that you're attaching most things to, I would recommend that you fix it first. And then as you can see, these ones have a minus on it, that means it's floating. So in order to get mates, you go to this little paperclip icon right there, and you can start creating relations between your parts. So I'm going to start. So for your coincident mate, this basically means that you're going to be attaching two sides of your part to the same face. So say I want this face right here to connect to this face of the block. I'm going to click the coincident mate, and I'm going to click this face, and I'm going to click this face of this one. And you see how they're kind of connected now, but they're on the wrong side. So we're going to use this tool called mate alignment, and it's either you either align it or anti-align it. But in my head, it's just if it's the wrong way, then click the other button and it'll switch that around for you. And now when you drag it, you can see that this face will only move in that direction. Do we have some chats? I can't see, but let me check. Oh, no, okay. So yeah, so we can see that this block only moves along that face. So if we want to secure even further with this bottom face down on the top face of the blue block, we're going to click mate again. And we're going to select, we're going to select the bottom face of this square and the top face of this blue block. And then now it should only slide in one direction. So basically mates, as you mate your parts, you're going to be limiting degrees of freedom that it can go. If you wanted to completely secure this, you could mate this face, to this face, and then now you can't move it around at all. So let me also show you that you can not only do faces, but you can also mate edges together. So if you wanted to create something like a hinge on a door, you could mate this edge of this block right here to this edge of this block. And now it'll rotate. Oh. So if you want to restart your mates, I would recommend you go to your property or your feature manager tree and go under mates, and you can select all of them and delete them or edit them if you would like. So I'm just going to delete these so they're not interfering. There we go. So now this block can move around completely. So we're going to click mate. We're going to click this edge right here. Nope, not that face. Can also do that. And this edge. And I'm also going to add a coincident mate between this face and this face. So now if you rotate it, you'll see that it works almost like a hinge. And there is a tool that you can use so it doesn't move through it, because that wouldn't happen in real life. You can go to move component. And it is going to work a little bit slower, but if you check physical dynamics, it'll work so that once you move this block, it'll stop once it hits something that it physically couldn't move through. And that is pretty much how to use assemblies. And now I will be moving on to my demonstration. So let me close out of this. Oops. So for my demonstration, I used the piece that Vicky created, and I also created 2 new pieces, but these are relatively simple. So if you guys want to follow along and make them with me, you can. I promise they are not very complicated. So I'm starting with a new empty part file, and I'm going to go to sketch. I'm going to sketch this on the front plane. I'm going to make sure my units are in MMGS, or else things won't fit together. So I'm going to create my sketch on the front plane, and I'm going to create a circle. Get my dimensions up real quick. So I'm going to create a circle on the origin, and I'm going to dimension that to 14 millimeters. You can change the dimensions of your circle right here when you create it, but if you want it to show on the part window, you can click Smart Dimension and then change it right here. So we want the diameter to be 14 millimeters. And then I'm going to exit the sketch, and I'm going to extrude it. So I'm going to go to Features, and I'm going to click Extruded Boss Base. And I'm going to extrude this to 150 millimeters. It doesn't matter which direction, since this pretty much completes this part. It's just going to be a rod. And that is what that one will look like. So I'm just going to save that as rod 1. Okay, so that is one part. And now we're going to create a new part file. And now, if you're following along with the presentation, it is step 4. We are going to create the cap that'll fit on the ends of the rod. So we're going to start another sketch on the front plane. And make sure our units are in MMGS, because mine likes to revert back. And then I'm going to create the general shape of it, and I'm going to dimension it afterwards. All right, so we want this to be 5 millimeters. We want this top one to also be 5 millimeters. This one's going to be 3. And then the distance from this side to this side will be 20. So now that we have that, we're going to add a sketch fillet. to these two corners, but I'm at 10 millimeters. So if I tried to click it now, it would say it would erase some parts because it's too big. So we are going to change it to 1.5 millimeters and then select our vertexes that we would like to fill it. And so this is the completed sketch of the cap. So in order to create it, we're going to exit and we are going to extrude revolve it or revolve boss it. So we're going to click the revolve boss right here. And we want it to go 360 degrees and we want it to revolve around this axis right here. And that is our created cap shape. And so we're going to also save that file. And so now in order to create an assembly, you could either click new and make an assembly. But since I already have this part open, I'm just going to go ahead and make an assembly from this part. And now we can see in the property manager tree that we have my cap and my rod, and I'm going to pin it so that it doesn't leave. And I'm just going to click the name and click into my assembly environment so that it places it. I'm going to do the same thing with the rod. Do one more of the cap because we need 2 of those. And then I don't see my base in here, and I could click browse and look for that file, but since I already have this open, then I will just drag it from my file explorer. So SolidWorkshop, and then my base. Oh, where is my base? Hold on, let me find my base. I believe it is. Okay, well, give me 2 seconds. This is the completed assembly that we've already used, but I will open it and retrieve the, actually give me 1 second. Let me find the base because I think I may have deleted it off my computer if I'm not seeing it. All right, sorry about that, guys. Let me start again. I just got it back. So now we have the base here, and we can add this into our assembly. So I'm going to open this window and tile it and just drag it from this open part file and place it in my assembly window. So now, in order to mate these all together, we have them all free floating, as you can see. Since I'll be mating everything pretty much to this base, I'm just gonna right click and fix it right here. And now I can't move this part around. So now in order to connect this rod into this circular hole right here, we're gonna use the concentric mate. So I'm going to click the mate button up here, and I'm going to click this surface of the rod. Oh, sorry, I'm going to clear that face. So I'm going to click this outside surface of the rod, and I'm going to click this inside surface of the base, and it should mate, like you can see, this rod into the base. And now we can freely move it around, but I kind of want it to be in the middle of this part. So we know that the base is about 100 millimeters long and the rod is about 150. So basic math, we want 25 poking out on each side. So we can use a distance mate between these 2 faces. So I'm going to select this one and set it to 25 millimeters. And that should lock it in place. So now in order to select to mate these caps onto the ends of the rod, we're going to use concentric mates and coincident mates. So you'll see that we need both after I show you what the coincident mate does from this surface to this surface. Also, you can see that it made it on the wrong way, so we can click the opposite alignment and flip it around. And now you can see that it is locked onto the rod, but it's passing through it, so we want it to stay on the end. So to do that, we want to mate this inside face of the cap with the outside face of the rod. And we're just going to repeat that on both sides. So now it will be mated to the end and you can't move it around. It's stuck right there. So we're just going to continue that. Coincident mate this face to this face. And check that. Another thing, you might need to check if your pieces are floating or fixed, because if one is fixed and you try to mate it to another one that's floating, it won't work. So this cap right here is fixed. So we're going to change it to float. And then we are going to mate it to the rod. So we can use our concentric mate to the rod. And then I will mate the inside face of the cap to the outside face of the rod. And that should complete our assembly. So notice you can't move anything around, everything's locked in place, and everything is where it should be. And that is how you would make something like a finished prototype. And if I had screws, I could place them in here. That is the completed assembly presentation. So I will pass it along to Trinity now.
Awesome, thank you. Yeah, so I'm going to bring back the slides if you'll give me just 1 second. Okay, here we are. Okay, so finally we're going to go over drawings, which is basically just a way to document your designs. Okay, so we'll go over these steps in a bit, but just to get started, you can create a drawing from an assembly or from a part, and there are also different templates that you can choose from, as you can see in the sheet format selection, a 0 through 4. Okay, there are also different views that you can present. So this is what we call the view palette, and this will be on the right side of your screen when you're creating a drawing. So you can add a top view, front view, right, back, and you can see some of these views represented here in this drawing. So you can also move them around, which I'll show in a bit. And there are different types, such as projected views, which are basically these views coming out from this one part, but I'll show them in more detail later. There are also model views, detail views, and section views, which we'll get into as well. Okay, and also for each view, you can modify what they look like. So these properties are linked between parent and projected views, which will be more clear later. But basically, you can change the display style to these different styles that you see here. You can also edit the scale or the size of each view. And finally, you can edit the sheet properties as well. There are also different annotations and add-ons you can put onto your drawing. We will use the model items tool to add these later on. You can also add dimensions using the smart dimensions tool, basically just like the way that you were doing with the parts and assemblies. You can also add notes. So I wrote on mine that EWB is the best org because it is. And finally, you can add a bill of materials, which is just like a list of the materials in your drawing. Yeah, so now I'm going to demonstrate how to make this beautiful drawing we have here of the assembly that Caitlin and Vicky made. So I'm going to switch over to SolidWorks. Okay, so the first step is to, I'm going to pull it up, go up to the File menu and then click Make Drawing from Assembly. I'm going to click No. I basically made this earlier, which is why that message is showing up. Okay, now I'm going to select A3 for the sheet format and click OK. All right, so now you can see that the view palette automatically opens. You can choose any different view that you want. So I'm going to choose the front view for now, and I'll drag it into this corner here. I'll also have to move zoom a bit to see what's going on my screen. I think actually my laptop is lagging a bit, so I need a bit of time. Sorry guys for this technical difficulty. I'm gonna see what's happening. Okay, so that glitched out a bit, but we can always get the view palette back by clicking in that this icon right here. So I'll drag it back in again. Okay, and now it's working, which is great. So now we're in the projected view mode, as you can see in this left corner. And so when I move my mouse, different views come out based on the angle at which they're coming out. So as you can see, if I just like go right up, it's the top view. And if I try to move around my mouse, it'll change to like automatically the 45-degree angle or the 0 degree or the 90 degree. So for this drawing, we want all three of those projected views. So I'm just going to place one here, another one over here, and finally the last one over here. And then I can right click to accept those changes. Okay. And now the next step is to add a detail view. So to add this view, I'm going to go back up into the drawing tab and select this detail view button up here. So what this will do is choose a spot of your part to basically zoom in on. And so I'm going to create a circular sketch just based on the tool that they have automatic. And this will be the section that's shown in the view. So as you can see, it's like a zoomed in version of that corner. And you can adjust the settings in the left, but because this isn't really a focus on the CSWA, we're just going to show you the basics. So yeah, I'll just place it down right now and click the green check to accept that change. Awesome. So now we're going to add a section view. So I'll go back up to this button right here, which is a section view. So the section view will basically use this line and cut through your part and then show you the view of that cut portion of the part. So I think this will be better explained visually, but I'll just go through a couple of the options that you have. So you can cut vertically, horizontally, diagonal, aligned, and there's also some half section options as well that you can always look into later. So I'm just going to use horizontal for this example. Select like around the midpoint of the part. There are different options, but again, because this isn't really our focus today, I'll just click OK, OK again, and then add the part, the view here. And I'll just check the chat for 1 second. Yeah. And yes, this workshop will be recorded and posted on YouTube. Okay, so moving on to the next step. Now we're going to add a diametric view from the view palette. So I'm going to go back into my view palette, find the diametric view, which is over here, drag it in. And this one we're actually going to customize. So I'm going to go into these options on the left and select this shaded with edges display style. So it's a bit, I guess, a bit prettier than the other ones. Then I'll use a custom scale for this view. So I'm going to set it to 1.5 to 1. Ooh, let's change that so it's right. And you'll notice that it got a lot bigger. So I can actually select this dotted edge over here to move it around anywhere I want. And I'm going to place the view right over here like we had it in the drawing for the example. Okay, next I'm going to add a bill of materials. So to add a bill of materials, we need to go into the insert and then tables option and then select bill of materials. And then we need to select a view. So this is all the same assembly, so I can really select any of them, but I'll just click this one. And then there's different templates that you can add, but we're not going to get into that today. So I'll just hit the green check. And as you can see, we have the item number, the part number, description, quantity for each aspect of the assembly. And you can also customize those parameters as well. But yeah. Okay, next is a sheet format. So I'm going to right click in the sheet format to edit it. And actually the reason why I'm doing this step is because even though I can edit any view by clicking on it, you'll notice that if you click like the edge or like the actual sheet itself, it doesn't recognize it. And that's because we're editing the sheet and not the format. So that's the reason why I'm right clicking on the sheet format and selecting edit sheet format. So now it brings us to the document. Okay, so the way I had it in the example was I had this edited and I called it the rod assembly. So I just double clicked and I just typed in what I wanted and it just recognizes it, just like maybe like Word or Google Docs would. So now I'll double click in here to edit this item and I'll say EFAC Workshop 1. And finally, I'll add my name in this column over here, or I guess this cell, we'll call it. Okay, and I'm just clicking outside to escape the function. All right, so now that we have our sheet format, I'm gonna go ahead and accept those changes by clicking this button. It's sort of like the sketch button, the exit sketch button. And now we're back to the sheet itself. Okay, so the final step is to add a text note at the top. So I'm going to go into the annotation tab and then click the note button. And then this will bring up this little box, which is basically your text box, like maybe like, you know, from Google Slides or stuff like that. So I'm just going to place it down and then type in engineers for a cause, solid workshop. Now I'm going to, oh, I spelled it wrong actually. So I'm going to fix that. And I'm going to Control A just to select it all and then set the font size to about like 48. I can also move, ooh, I'm actually going to move this by, so I don't know if you can see it, but there's like a tiny dot in the corner and that's what I click to move it. Yeah, so now that that title is centered, we have our finished drawing. So this will sort of be like your certificate for ending the workshop. So does anyone have any questions about anything that we presented today? Okay, well, if not, this is the end of our workshop. So thanks everyone for coming. Also, thank you so much to Vicky, Caitlin, and Jeremy for helping out with the prepping of the workshop. Yeah, hope you guys have a great weekend, a great rest of your Friday night. And yeah, we'll be hanging out for a while if any questions come up or anything. So yeah, thanks everyone.
I have a question. Wait, so is this like a part in a series?